Everyone, we have finally made it to the end of activity 7 with lesson 7.3. Big stuff today, talking all about perpendicular lines finally, officially. Okay, and this is starting on page 84 in your springboard book, and you're going to want a pencil, a highlighter, and possibly a calculator as well. Okay, so on page 84, we see this picture here, and we see this lovely definition that I definitely underline, highlight here, that's perpendicular. And perpendicular means that we have lines that intersect to form right angles. So for instance, we have this line, and we have that key. If we know they're perpendicular, they're forming right angles. And officially there's 4 right angles here when we have the right lines. Remember, the perpendicular symbol is this guy right here where it looks like a little perpendicular intersection. Okay, now what they're telling us here and down here is if we lay 2 stakes, and similar to what we've been talking about in the last 2 lessons, if we draw some lines through some points here, it's terrible drawing there, but if we have these lines here, and then we draw another line somewhere through here, and if we are able to measure these, so let's say we measure these, and I'm telling you I got the measurements that this is 90 degrees, and this guy here is also 90 degrees, right? Well, first of all, we know that we could put this box here. We know that these lines are perpendicular, okay? And we also know that these lines that the 2 lines that we drew in are parallel to each other because their corresponding angles are congruent, right? So we have a couple things that we could talk about here, and that's the idea that we can draw in lines that are perpendicular to every line. There's always ability to draw something in that's perpendicular as well as parallel, right? Those are some postulates. So to make sure we accurately do that, we would want to measure it to make sure that relationship holds. Now that also goes with the idea of the perpendicular transversal theorem. And basically what that tells us is if we have these 2 parallel lines, right, and we know that these lines are parallel to each other because we know that angle 1 is congruent to angle 2. 1, angle 2. Say we know that these guys are congruent. We know that the lines then are parallel. Let's call this line M and line N. So we know if those are congruent, these guys are parallel. And if we know that these each measure 90 degrees, we know that the lines have to be perpendicular. Then let's call this line here line L. So we know that M is perpendicular to line L, which means that also line N is perpendicular to line L because of the fact that these guys are perpendicular and parallel. But this would also have to hold true as well. So we can have the perpendicular relationship as well. So if these guys are parallel and you know at least one of them is perpendicular, then the other guy also has to be perpendicular. Okay. Now this also leads us to the idea of what a perpendicular bisector is. So here it says that we have segment AB, and we want to draw a line XY so that it is the perpendicular bisector of AB. So here's AB. AB. This is our segment. And we're going to draw in this line so that we could say this is the perpendicular bisector. So this is line X, Y, and they said that it's going to intersect this at point M. And if I'm telling you, hey, this is the perpendicular bisector, you're allowed to make mark your picture 2 ways. So if this is the perpendicular bisector, what it's doing is it's cutting our segment into 2 congruent pieces. So that's where the bisecting part comes in. And then, of course, the perpendicular part of this is knowing that we have created 4 right angles here. So those each have to be 90 degrees. Okay, that's our perpendicular bisector. So we're allowed to say a couple things in this case. First of all, that line XY is perpendicular to segment AB. This is my line symbol. Those are arrows. And again, we are allowed to say that BM is congruent to MA because of that bisection. And finally, of course, that M is the midpoint. Those are some conclusions we can draw there. All right. Moving right along then, we are going to kind of finish off talking about this lesson. It's almost done here. We're going to jump down to number 7. And number 7 goes back to what we were talking about on the last page with the perpendicular transversal theorem. Because if we have lines A, B, and C, and they're all on the same plane, and we know that they're telling us A is perpendicular to B. So I'm going to start by drawing that. Here's A, here's B, and they're perpendicular. So I'm going to mark my picture. And then they're also saying that B is perpendicular to C. So I'm going to draw in a line C that B, our guy right here, is perpendicular to. What now can we conclude about A and C, right? Are these two lines perpendicular to each other, line A and line C? Well, no. Very similar to what we drew back over here on the last page. This looks very similar to this picture, and we know that these guys are, A and C are not perpendicular to each other because they're not touching each other. A is not touching C. In fact, what they are is parallel to each other. Line A is parallel to line C because their corresponding angles are congruent. They're both right angles. So can we conclude that A is perpendicular to C? No. A is parallel to C because the corresponding angles are congruent. Okay? So these guys are parallel, not perpendicular, A and C. Then down here for number 8, they're telling us that RS is the perpendicular bisector of JL. So it's cutting JL in half. Can we also say that K is the midpoint of RS then? The answer here is no. K is the midpoint of JL, but RS may or may not be getting cut in half. It just is the perpendicular bisector. So we would have to know that JL is also the perpendicular bisector of RS if we were going to truly mark that. Okay, so in this case, there's not enough information to be able to tell. All right, last 2 examples I want to do with you. The first one is number 12. In number 12, we're going to start by drawing the picture because it says we have a perpendicular bisector of segment CD. So we're going to start by drawing that. Is going to intersect it at point P. So here's point P. And again, it says it's the perpendicular bisector. So we know that this guy's equal and that we have the right angles. Well, they're telling us that from C to P, this is 12. From C to P is 12. And they want to know then, what is the measurement of C to D, the whole thing here? Well, again, knowing that this is a perpendicular bisector, if CP is 12, PD is 12. And together then, this would have to be 24 is the length of C to D. Okay. Finally, number 13 is asking us kind of for an idea of a picture. If we have 2 lines that are intersecting and they're telling us that the angle that they created is obtuse, could it be perpendicular? Well, think about an obtuse angle. 170, 130, maybe even just 91 degrees is obtuse, right? Anything bigger than 90 degrees. Well, if this is 91, this guy would have to be 89. And this guy would be 91, and this guy would be 89, right? If this is obtuse, it's not a right angle. This is not creating 4 right angles, right? These are all different angles. So could these lines be perpendicular if the angle is obtuse? No, right? Not for 90-degree angles are going to be formed, right? We're not going to have four 90-degree angles on that. All right, thanks everyone. Made it to the end of activity 7. Make sure you let me know of any questions on any of this stuff, but more in particular these perpendicular lines.